recap. We know that sine is opposite over hypotenuse. We know that cos is adjacent over hypotenuse, and we know that tan is opposite over adjacent, okay? And we dealt with this in a singular triangle, and we identified those sides. So in a normal triangle, your opposite and your adjacent will change depending on where your reference angle is. So we have a triangle here. For theta in black, that is my opposite, that is my adjacent, and that is my hypotenuse. For beta in red, my different reference angle, here's my adjacent, there's my opposite, and my hypotenuse stayed my hypotenuse. Different triangle, beta is there, so opposite, adjacent, and hypotenuse in red. There is theta, opposite, adjacent, and hypotenuse in black. That is where we started, right? Then we moved on to the fact that we can take this triangle and put it on the Cartesian plane. And when we did that, we found that opposite over hypotenuse always was y over r. And cos was always x over r, and tan was always y over x. And we found my r value by doing Pythagoras.
Was this on the work? On the work thing you printed, man?
Yes.
So is it continuing from
Yes.
Okay.
So this was that last question of the exam, or the test, okay? So what we're going to do now is we're going to see, or we found that in quadrant 1. We are now going to see, does this hold true for quadrant 2, 3, and 4? Can we say that on a Cartesian plane, sine will always be the y value over the r? Will cos always be the x value over the r? And will tan always be y over x? Because we saw it in quadrant 1. Right? Let's just confirm. There's my theta. There's my opposite. There's my adjacent. So cos is opposite y over hypotenuse r. Sine, opposite y, hypotenuse r. Cos is adjacent x over hypotenuse r. And tangent is opposite y over adjacent x. So in that first quadrant, that is what it looked like. Now, still kind of a recap, but we're just going to confirm that that's true in every other quadrant. So I want you to draw the following, please. So is this true in all 4 quadrants? You can start by doing your first 2 quadrants, please, and then I'll shift up for you to see quadrants 3 and 4. Erin and Zora, Chardonnay, you're going to have to work quickly. Need to finish that and the next page. So this would follow on exactly after the last time we were in class. So you're going to eventually have all 4 quadrants, so make sure you have space to write stuff in the bottom 2 quadrants as well. I'm just leaving the information up for the top 2 quadrants first. Okay, and then your bottom two quadrants. It's just a random point. Sine theta, cos theta, tan theta, the name of the quadrant, and the letter T in that one, and the letter C in this one.
Ma'am, can you move up just a little? Just
That's as much as I can move up for now.
see the anything above like the correct. Oh, you just need to get a.
Okay, I'll go back to the top later. Let's finish the bottom. So just the point, the coordinates, sine theta, cos theta, tan theta, quadrant 3, the letter T. Point, sine theta, cos theta, tan theta, quadrant 4, and the letter C. I'm just going to zoom out so you can see everything at once. It's a bit small, but at least you can see everything. Okay, so let's start. Just waiting for 2 to finish. Okay, can I zoom into quadrant 1? Okay, quadrant 1. So we have our triangle, and I have an arbitrary point, which we know will be a positive x and a positive y, right? Okay, because it's on the positive x side and the positive y side. Now, sine theta, there's my theta, would be opposite, which is y, over hypotenuse, which is r. Cos theta would be adjacent, which is x, and hypotenuse, which is r. And tan theta, opposite, which is y, over adjacent, which is x. Now, very important, I did not put my positive signs in because I knew that they were all positive. But technically, this is positive y over positive r, which is positive. Positive x over positive r, which is positive. Positive y over positive x, which is positive. So sine, cos, and tan are all positive in quadrant 1. And that is what the A stands for. All positive in quadrant 1. Now let's repeat the process in my second quadrant, and I'm going to use a different color. So there's my arbitrary point. I know that x has to be negative and y will be positive because it's in the positive y axis. So let's connect it to the origin. And how am I going to form my 90-degree triangle? Am I going to form it that way and have a 90 degree? No, I will always form it with the x-axis. So my theta, be careful now. My theta always goes from here to the time it touches the hypotenuse. Always starts at the positive x. My new theta. That is still the opposite, but it is my y value. This is my adjacent, but it is negative x.
Ma'am, why is it negative x?
Because it's on the negative x side of the axis.
Oh, yes.
Okay. Now I need an r value. I need to know if r is going to be positive or negative. Now I want to remind you of something. Pardon? Yes, that's what I'm saying. Remind you of something. I just want to find this paper. So if I have negative x and it is squared, and I have negative y and it is squared, negative times a negative is a positive. And a negative times negative is a positive. So no matter what x and y are, because we are squaring them, r always has to be positive. Because we are squaring those negatives. So r is always positive, and the true value we would find by doing Pythagoras. So now we can do sine, cos, and tan again. Theta, opposite over hypotenuse. And it is positive y over positive r. Cos, adjacent, we now have a negative x over hypotenuse, which is r. And tan, which is opposite y over adjacent, which is negative x. So we have sine, positive. Cos is negative. And tan is? So which is the only one that is positive? So sine is positive. First quadrant, A stood for all positive. Second quadrant, S stands for sine positive. And therefore cos and tan must be negative. Because sine is the only one that's positive in that quadrant. So if you now pick up the letters, which function is going to be positive in quadrant 3? Tan. That means sine and cos has to be negative. We repeat the process in my third quadrant. Connecting my origin to my arbitrary point. My arbitrary point has a negative x and a negative y. Anyone still busy with quadrant 2? Moving to quadrant 3. So I have a negative x because it's on the negative x side, but I also have a negative y because it's on the negative y side. Once again, I always connect it to the x axis for my 90 degree. And my theta still starts at the positive all the way until it meets my hypotenuse. Still have negative x, negative y. Squaring both of those would mean that r has to be positive. And once again, we repeat the process. Opposite is negative y over r. Cos is adjacent, negative x over r. Tan is opposite, which is your y, which is negative. Your adjacent, which is x, which is negative. But a negative divided by a negative equals a positive. So sine is negative, cos is negative, but tan is positive.
Minus is on top, is that for the same one?
I'm using this, well, it doesn't match, but yes. It's just an arbitrary point which we know has to be a negative x value. So the T stands for tan is positive in quadrant 3, therefore sine and cos are negative. And then you can do the fourth quadrant as well, please. Repeating the process of what we've just completed. Connecting the origin to the arbitrary point. Connecting the triangle to the axis. Positive x, negative y, but positive r. Theta goes from the positive all the way around until it hits the hypotenuse, which means that y is still opposite, x is still adjacent, and r is still r. So we call this the cast diagram. C, cos is positive. A, all is positive. S, sine is positive. And T, tan is positive. Anyone so busy? Taking it off in 10 seconds. Okay, let's look at an example. So which quadrant am I in? What is the number of my quadrant? Third quadrant. Which function do we expect to be positive in that third quadrant? Tan. And sine and cos we expect to be negative. Let's check. My x value is negative 3. So I'm going to put negative 3 in my x. My y value is negative 4. So I'm going to put negative 4 in my y. I still need to know what r is. R is my hypotenuse, which means the x squared plus the y squared. Negative 3 times negative 3 is positive 9. Negative 4 times negative 4 is positive 16. 9 plus 16 is 25. Square root of 25, I still get positive 5. So I can put that on my diagram as well. Okay? So now I have all three sides, which means I can find the ratios for sine, cos, and tan. Sine would be y over r, so minus 4 over 5. Cos would be minus 3 over 5, adjacent over hypotenuse. And tan would be opposite over adjacent, which would be negative 4 over negative 3, but that is just positive 4 over 3. So as we expected, sine is negative, cos is negative, but tan is positive. And therefore, to find theta, we would take any one of the three, does not matter which one. I'm going to take cos just because I feel like it. To find it, and we're going to get something that feels like it doesn't make any sense, but later in the week you will. So shift cos negative 3 over 5 gives me an angle of 126,87, which actually does make sense. No, it doesn't. Yeah, currently it doesn't make any sense, but that would be your answer, and it would get marked. Okay? Because actually we should get something bigger than 180, right? Because here's 180, and it's slightly more. But later in the week we'll see why that is still a correct answer. It's got to do with the reduction formula. So we could obviously get it that way, like we see it. I give you a diagram, I ask you for sine, you give me the ratio, I ask you for theta, you do cos minus 1 and the ratio, that's all fine, okay? But there is another way that I can ask this question. So it can be presented in a different way. And this is how it could be presented. So it says, let's try and keep as much information in there as possible. I give you negative 5 sine theta minus 3 equals 0. I also tell you that theta must be between 180 degrees and 270 degrees. So that's telling me that that must be the third quadrant. No, because that's the only way I'm going to find between 180 and 270. There's 180, there's 270, so it must be in between those two quadrants. Okay? But now what? How do I know what those values are? How do I know what the hypotenuse and my y value or even my x value is? So now I go back to this information and I'm going to manipulate it. So that's what I was given. Okay? Now I want to get sine theta on its own. Sorry, that's what I was given. So I take the negative 3 over, becoming positive 3. I still have a negative 5 in front of the sign. So now I'm dividing, so I get negative 3 over 5 as my ratio. So I know that this is opposite over hypotenuse. Or in a diagram on a plane, we know that it has to be y over r. But sine is negative. Where is sine negative on my cast diagram? Well, that means it's positive, that means it's positive, so it's either here or it is there. So how do I know which one? Well, the fact that I said it must be in quadrant 3. It must be between 180 and 270. So that, hold on, that takes out my fourth quadrant. Therefore, it has to be in my third quadrant. And then you would draw the diagram yourself. So before I gave you the diagram, now I'm giving you the tools and you must draw the diagram yourself. And we'll do that tomorrow.